All right, so the embedded question here was that you were supposed to just review from section 6.2 and solve this the way that we had already solved it from 6.2. So what was the big deal about solving from 6.2? How did we go about doing, what was the tip that I kept telling you? Yeah, get bases alike. And so that's going to be the first thing that we want to do. And so what base did you use on this? A base of 3? Okay, so if you're using a base of 3, what's going to be on the left side? Okay, tell me the whole left side. What? Don't, what?
3 to the power of 2x equals 3 to the power of 5.
I don't have time for that. All right, so 3 squared is going to replace the 9. So we're going to have 3 squared raised to the x power, and 243 is going to be 3 to the 5th power. Our bases are alike, so now I can make my mini equation. When you raise a power to a power, you multiply your power, so that's 2x equals 5. We're going to divide on both sides by 2, and we have x equals 5 halves. No big deal. That was section 6.2. So that's just totally a review. So then what I said, well, what do we do if you can't get your bases alike? So for instance, if you look at example number 2, there is no way on earth that you can make a 2 base and a 5 base alike. I can make a 9 and a 243 alike, but I can't make a 2 and a 5 alike. So what in the world do I do then if I cannot make it? For the record, making bases alike is the easiest method. It's the easiest method, but sometimes it's not a possible method, like in this case. So in your video, I walked you through taking a logarithm of both sides, and for the record, you can do a common or a natural log, either one. And a lot of times my students say, Ms. Roberts, which one should I choose, the common or the natural? Did I go into the video? Okay, so then you tell me, how do I know which one to choose? Very good. So if I have any 10s in the problem, let's use the common log. If I have any e's in the problem, use the natural log. And what if I don't have either one of those? Eeny, meeny, miny, mo. Pick the one that you feel like choosing. All right, so I'm going to start with example number 2, simply because that's the one that I was referring to. I don't have any e's. I don't have any 10s, okay? So I'm going to choose this time around, I'm going to choose the natural log because in the video I choose the common log and I don't want the natural log to feel left out. Okay, so I'm just going to natural log both sides. Now, once I do that, then I can use my rules. Okay, so on the left side, what rule can I use? Yeah, it's that power rule that says when I have a log and I'm raising to a power, I can bring that power out front. I can multiply my power. Am I writing this correctly? X plus 3 times the natural log of 2. Around what? Yeah. Right, how come?
Because it's grouped together in the
The way I've written it right now, what am I multiplying? Just the 3. And it's the entire power that needs to be multiplying by my natural log of 2. Now, one thing that a lot of my students get hung up on here is that they have a hard time seeing natural log of 2 as a number. It's just a number. Like if you really wanted to, you could even find its value in your calculator. You don't have to, but you could. It's just a number. Okay, so you need to understand that natural log of 2, this is a constant. It's literally like saying x plus 3 quantity times 5. It's just a number, it's just a constant, okay? All right, so on the other side then, what kind of math can I do on that side? Yeah, power rule again. So let's take our power out front. So we have x times the natural log of 5. And once again, my natural log of 5, that's just a number. Okay, now let's visit junior high for a minute, all right, just for a second. If I had had you in junior high and I had said, okay, I want you to solve this equation. And I said, I have an x plus a 3 times a 4 is equal to I don't know, 3 times, an x times a 3. If I had given you something like this in junior high, what would you tell me to do first if I was telling you to find the variable or go solve the equation? You would distribute, okay? Now, this isn't any different. Remember that I just got finished saying that these guys here, these are constants, so is the natural log of 2 and so is the natural log of 5. So really it's the same kind of equation that I have. All right, so then we distribute. So if I'm gonna distribute, what does that look like then? I'm having technical difficulties. Hang on just a second, please. All because I forgot to charge. All right. So I want to take my constant and I'm going to distribute it to both of these guys. So we have x times the natural log of 2 plus 3 times the natural log of 2 is equal to x times the natural log of 5. Okay, so then if that's what I have, again, let's go back up to junior high for a minute. If we had done the same thing and we had had 4x plus 12 is equal to 3x, what would we have done at that point? So what exactly are you telling me generically? What are we trying to do? Combine like terms, exactly. So any of the terms with x's in them we want to get together. Well, guys, that's exactly what we want here. You see that I have 3 terms, 2 of them have x's in them. Let's get those x's on the same side so that we can try to combine them. Now, they're not gonna be like terms, but still we can get those x's to one side. So let's subtract on both sides by x ln of 2. So we've got 3 natural log of 2 is equal to x ln of 5 minus x ln of 2. Can you remind yourself and me, what is it that we're trying to do here? Solve for x. And the problem is that I have multiple variables right now, and somehow I need to condense them into the same variable. So what kind of junior high math could I do here?
GCF.
Yeah, what is the GCF? Leaving you with?
Would you leave them separate? The natural log of 5 minus the natural log of 2?
Yes. And what were you debating in your mind there, Devin? What was the other option?
I was thinking about what we did in the last chapter. We converted them to natural log of 5 and 2.
Ah, gotcha. You actually could do that. You could do that. Where you condense? Yeah, you could do that. You could do that. All right. And then on the other side, I still have my 3 times the natural log of 2. And I still might do that, Devin. Okay. So at this point, I can get my x alone by division. So I'm going to have 3 natural log of 2 all divided by the natural log of 5 minus the natural log of 2. All right, now I want to make a couple of comments about this answer, and Devin's already alluded to this. Let me go back up to the directions because I didn't make you read them. Notice that my directions have 2 parts. First, give an exact solution. The word exact basically means exact, no decimals. Decimals are approximations. Okay, and so exact solution would be something that doesn't have any decimals in it. And then part B, give a solution that is an approximation, that's rounded to the nearest thousandth. So I want to make a couple of comments here about what Devin said. First of all, there is a lot of cleanup I could do with this. I'm totally fine with this line right here as an answer for your exact solution. I'm fine with this. But you need to understand, I don't remember and I don't know if my lab is okay with this. So let's talk about some things that you could do to simplify it a little further before we plug it into the calculator. The first thing I could do is understand that this is a power, right? When you have that number out front. So I could rewrite the top as the natural log of 2 cubed, which is 8. Right? So the top could be rewritten that way. And like Devin said, the bottom could be written as the natural log of 5/2 because of the quotient rule, okay, from the last section. Now, this is as far as it can be taken. Remember, the quotient rule is a log of 2 things being divided, okay? This is 2 logs. So this is not the quotient rule right here at the bottom. Okay, so this is as simplified as I can possibly make it and still make it exact. But understand, I'm okay with either of those lines as an answer, personally, okay? So even if my lab counts it wrong and I'm grading your test, I would go back in and I would correct that. I would give you the points back for that, okay? Now, for an approximate solution, you need your calculator for this. So if you're going to enter in the first one, you need to make sure that you remember that you've got to put parentheses around the entire, really the entire top, although in this case, it's not going to make a difference, but it will make a difference if you don't put parentheses around the entire bottom. Okay. And it said that we were supposed to get an approximate solution, I think, to the nearest, did it say 1,000th? Are you guys getting that this x is approximately 2.269? That's what you should be getting. Okay. So again, there's 2 separate answers. You've got the exact version, whether it's this one or this one, I'm okay with. And then this is part A, and then part B is my approximate solution. Of course, you have to get the exact solution correct to be able to get the approximate solution correct. All right, let's look at number 1. Since getting like bases is automatically easier, I still always ask myself, can I get like bases on this one? Okay. And so when you start to look at this one, what's your knee-jerk reaction? Do you kind of feel like, yes, I can get like bases, or no, I can't? What could you turn the 6 into to get a 3 base? Well, because of that 1 over. Yeah. So I agree with you. But just think about what 6 is made up of. Can it be written as a 3 to the first or a 3 to the second? 3 to the first is too small, 3 to the second is too big, right? Because 6 is 3 times 2. It's that 2 that's messing things up. You can't turn 6 into a 3 base of any sort. So there's no way on earth that I can get my bases alike on this. So since I can't get my bases alike, we're going to log both sides. And we'll stick with the common log because I just finished doing the natural log. There's no 10s, there's no e's. So pick the one you want and run with it. So power rule on the left side. So we've got x times the log of 1/3 is equal to the log of 6. And then what could you do with this? By what? Yep, so we got log 6 divided by log of 1/3. By the way, there isn't any way at all to clean that up. Actually, I could take that a little further. I'm okay with this as an answer. I'm okay with that as an exact solution, but let me show you something that my lab might do. On bottom, how could you rewrite the bottom? You're gonna have to tell me what your thought is on that one. Oh, see, you didn't say that. That's interesting. 3 to the negative first power. Okay, so that's totally an option, Sierra. And I wasn't even thinking of that option. Were you guys thinking of anything else? What about the quotient rule? What would the quotient rule look like? Log 1 minus log 3. And what is any log of 1? 0. And so now you have 0 minus log 3, which is just a negative log 3, which is what Sierra said, negative 1 log 3. Okay, so either way, I'm getting to the same thing. So my lab could force you to take that step. I don't know if it will or not. Either of those two, though, is good for me. Let's go get an approximate solution. Can you guys find me an approximate solution? Is that what you guys got? Becca, how you doing over there?
Good. I'm trying to type it in right now. I keep talking and then my mic's not on, and then I'm sniffly snotting when it is on.
Oh, I knew I hadn't heard from you in a while. That's why I was checking in on you. Oh, that's funny. Well, you can keep your sniffly snotty stuff. Maybe we should thank you for not coming today, huh?
I got 1.255.
Uh-oh, we got negative 1.631.
Oof. I must have typed it in wrong.
Which one did you type in? The log 6 over negative log 3 or the log 6 over log 1/3?
The 1/3.
Okay, that shouldn't be a problem. That should still give you the same thing. Devin, did you get what we got?
I forgot to put in the negative, but when I did that, I got 1.6309.
And the 0.9
Would round
to 1.
Yeah.
Mm-hmm.
And then I put,
Okay.
and I think I might have put the negative in at the wrong place because it's an error. So I'm gonna do the 1/3.
The negative shouldn't have been a problem, but you're right. It might be in the wrong place. Becca, did you get it that time?
I got the negative 1.6309. So
Okay, yeah. All right, so let's look at example number 3. Does it look like we can make our bases alike on this one? I mean, changing a 9 base to a 9 base? Looks to me like we could, right? Looks to me like we could. So let's see if we can. And by the way, we're gonna get to the bottom of this one, spoiler alert, and we're gonna go, oh yeah, duh. We've run into a couple of those this semester, okay? So we're gonna get to the end of this and go, oh, yeah. All right, so what could we do on the left side? Abigail, I know you like using these, so what can we do on the left side? Yeah, negative power, so how could I rewrite the left? Mm-hmm. 9 to the negative x power is equal to negative 9. What's the power on that negative 9? 1. Are your bases alike? They're not. One's positive and one's negative. Now, when was the last time that a positive number equaled a negative number?
never.
Never. Okay, and I really could have even seen that up at the original because I can tell this is a positive number. And I can tell that this is a negative number. So from the very start, I could have said, yeah, there's no solutions to this. There is no X in the world that I'm ever going to be able to plug in that will cause a positive number to equal a negative number. Now, since we can't get the bases alike though, let's pretend that we didn't think about that. Okay, since we can't get the bases alike, let's log both sides and let's see what happens. All right, so let's see, what did we use last? A common log? Let's use a natural log. What rule can I use on the left? Power rule. So we've got negative x times the natural log of 9 is equal to the natural log of negative 9. And if I'm trying to solve for x, what would I do? Divide by what? Good, good. So I have x is equal to the natural log of negative 9 divided by the negative natural log of 9. And so like if I hadn't gone through the logic to say, well, that totally, I can't make those alike. If I hadn't gone through that logic, so far this looks good. Plug that into your calculator, see what happens. Not a real answer. Yeah, you should get an error of some sort. Okay, and so this leads us to a new rule. You cannot take the log of a negative number. You're not allowed to take the log of a negative number because it will give you an error. Okay. So then once again, we'll go down here and say, nope, no solutions. And so now it makes more sense. Logically, I can't make a positive equal a negative, but then we've also mathematically shown it's just not an issue. It's not a possibility. Now, in order to do the next question, I need one of these two tips. And I'm going to refer you back to the sticky note multiple times today. So make sure you have both of them. So let's look at tip number 1. When your unknown is in a power, okay, so that's what you're looking for the first tip. Get the base and power alone and then log both sides. We'll talk about that. But then number 2 says, when you're solving a log equation, get the log alone. Okay, so understand that I have 2 different types of equations here. The first one, when my unknown is in a power, so this is an exponential. This is an exponential equation because we're talking about the fact that the unknown is in my power. And the second one is a log equation. Okay, so understand these 2 tips, memorize them, really get a hold of them because you're gonna use them over and over and over again. All right, so when you look at number 4, should I be using tip number 1 or tip number 2? 1, because the beginning of number 1 says when your unknown is in a power. Oh, guess what? My unknown is in a power. So can you read me the rest of tip 1? Because I didn't pay any attention to what the rest of it said. When the unknown is in a power, what does it say to do? Okay, let's stop right there. Get the base and the power alone. All right, so tell me, what's the power in this question? 3x minus 2. Good. What's the base in this question?
1.2.
All right, is it 5 times 1.2 or is it just the 1.2?
Just the 1.2.
It's just the 1.2. Remember that very early on conversation in like the first week of classes, Devin, I think you were the one who was slapping somebody. Am I remembering correctly? Yeah. Somebody over here was slapping, yeah. And so remember we were talking about how the base is the thing that can do the slapping of the power, right? Whatever's being raised. So 1.2 is the base. 5 is not part of the base. My power is not connected to the 5 at all, okay? Because my 5 is too far away to be slapped by that power. So tip number 1 said when your unknown is in the power, get base and power alone. So I need these 2 to be alone. So what can I
Divide by
do
5.
mathematically? Yeah, what did you say, Becca?
Divide by 5 and then get the 1 to the other side.
All right, in that order?
Well, you can do it the opposite way.
Can I do it
Do-
either way?
Yeah.
Okay, so let's go back to junior high for just a minute. If I had 5a
no.
plus 1 equals 11, how would you get a alone, Becca?
You subtract 1 to the other side and then divide by 5.
And does it matter which one you do first, Becca?
Yes.
Yeah, it does. So it's the
Yes.
same concept here. It's gonna matter which one you do first. So let's move the 1 first, and that'll give me a 10. And then we'll divide the 5. Does that make sense, Becca?
Mm-hmm.
Crazy how all we have to do is revert back to junior high for a second, and Math 110 all of a sudden just makes sense. All that stuff we learned actually meant something. All right, so can you go back to your tip? Your tip said get the base and power alone. And then what did it say to do next? Log both sides. And by the way, on the right side, I know it says 10 over 5, but what is 10 over 5? 2. So let's make this equal to 2. So we're going to log both sides. Why are we logging both sides? What's the base on the left? 1.2. What's the base on the right? 2. I can't make those alike. Okay, so since I can't make my bases alike, now if I could make my bases alike, I would totally do that. It's easier, right? But since I can't make my bases alike, I'm gonna log both sides. What did we use last, common or natural? Natural, let's use the common. And by the way, it's still an eeny, meeny, miny, mo. I don't have any 10s, I don't have any e's. So we've got the common log of both sides. What's the goal here again? Solve for x. Okay, so what can I do on the left side? Power rule, yeah. So we've got 3x minus 2 times the log of 1.2. Is this a good way to write that? No, don't forget the parentheses. Is equal to the log of 2 on the right side. No, my brain goes in 2 separate directions and both of them are correct. So I want to ask you, what would you do? You could. What's another option? Divide by log of 1.2. Both of those is correct. And maybe you're thinking, but Ms. Roberts, how come a few minutes ago we had to distribute when we were looking at one like this? So may I take a break for a minute and I want to explain why we had to use distribution a minute ago. How many x's did we have in the whole thing? We had 2 x's. I had to separate that x out. And that's what distribution did for me. In this one, how many x's do we have in the whole thing? 1. All I have to do is just single that x out. Okay, so you can distribute, that's correct, or you can just simply start stripping things away from the x. And so that's what I'm going to do. I'm going to divide log 1.2 on both sides. So that'll give me 3x minus 2 equals log of 2 divided by log of 1.2. Okay, so if I'm stripping things away from the x, then what would be stripped next? The minus 2. So that's going to be 3x equals log of 2 divided by log of 1.2 plus 2. And then what's the last thing that would happen? Divide by 3. So this is starting to get a little ugly. You're right, Becca. So x is equal to log of 2 divided by log of 1.2 plus 2, all divided by 3. Now, that is the exact answer. Okay, that's the exact answer. You can't clean up the logs in any way. Okay, so I mean, there's one other thing that you could do. You could multiply by the reciprocal with that 3, but I would say that's not necessary. Okay, so this is an exact answer. You guys go find an approximate answer. What you got?
1.934.
Okay, so Sierra got 1.934. Yes, yes. No. Okay, don't erase anything. Let me see. Wait, this should be 1.2. Log of 1.2. So 1.934. Becca, did you get that?
No. I got 0.7406. I guess I'm confused on how to type it in the calculator.
Okay,
I did
so
just one single log, and then in the parentheses that comes after, I did 2 divided by 1.2, and then closed the parentheses, then did plus 2. I think that's maybe where I went wrong. Like, should I press log twice for each number? Or no?
there should be a log in front of the 2. There should be a log in front of the 1.2. Becca, this is what the beginning of your
Okay.
calculator screen should look like.
Okay. Yeah, I just did log one time.
And that's a problem. Now, if you type this in and push enter, and then to that, just type +2 and your screen will say answer +2. Push enter.
Mm-hmm.
And
Yeah.
then to that, do divide 3, and your screen will say answer divide 3, and you should get the 1.934. Does that work?
I got it now.
Okay. If you wanted to type on the entire thing, you would need a set of parentheses around this guy.
All of the, yeah.
Then you would need another set of parentheses for the +2. And
Well,
then
actually, I got the same answer with typing in the original log thing that you said, and it puts parentheses around the number, and then I just added the +2 at the end, and then got the answer, and then divided that by 3.
Okay, yeah.
It worked.
Yeah.
Yeah, I got it.
That's good. Okay. All right. So then let's go to number 5. So now we're backing off a little bit, and I'm only telling you to find the exact solution. So on these, I don't actually have to find an approximate solution, just an exact solution. So which tip should I use? Tip number 1 or tip number 2? Tip number 2. And what does tip number 2 say? Okay, so we're going to get the logarithm alone. Now, why do we look at this and say that the log is not alone? What's with it? The 3. Okay, so we need the log alone. Now, there's actually 2 ways that you can get the log alone. So what are your thoughts?
Divide by 3.
All right, so we actually had both of them said right there. So Sierra, can you say that louder? You can make it a log of x cubed, which is using the power rule. And Becca, what did you say?
I said divide by 3.
And you're exactly correct. Both of you are correct. Okay. So Sierra, what I'm going to do is I want you to solve it the way you said. Okay. And then I'm going to solve it the way that Becca said. And the other 3 of you pick one and run with it. We should all land in the same spot at the end. Okay. So Becca said that we should divide by 3 on both sides. So this is going to be log of x is equal to 2/3. Okay, so what was it that tip said again? It says when you have a log equation, it said to get the log alone, and then what? Oh, exponential form. Okay, so now we're going back to that conversion from 6-3, where we turn a log equation into an exponential equation. All right, and in order to do that, in that lesson, I taught you to use an E since we want the exponential. Do you remember that? Okay, so what does this look like then as an exponential? Now, wait, where are you getting a 10 from?
That's the original log base.
Oh, this is a common log, and all common logs have a base of 10. So 10, now I interrupted you. What did you say next?
To the 2/3.
To the 2/3 power is equal to x.
X.
Now, I got x alone, okay? But I'm thinking that there's some cleanup we can do with 10 to the 2/3 power. Now, Sierra, what did you get there? You got 10 to the 2/3 equals x?
Well, really, it's the cube root of 2 squared.
Oh, okay, interesting. All right, so let's use, okay, good grief. Look at all these rules that I'm pulling up. I just now used the 6-3 rule about turning into an exponential. And now I'm about to use the, I think it's the 6-2 exponential rule that talked about what a fraction power means. Okay, and so, man, there's a ton of rules for you guys to remember. That's a hint. Okay, you have to know the rules. Think of your rules as your tool belts, the tools in your tool belt. If you don't bring your tools to work, you can't do the job, right? So all of these little rules that I keep giving you over and over and over again, these are the tools in your tool belt. Bring them to work or you can't do your job. All right, so we've got here, what does the bottom number mean? It's the root number. So we've got the cubed root. And what does the top number mean? It's my power, so I have 10 squared. I did say that. That's exactly correct. Now, the reason I put it on the inside is because in my mind, it's easy to do 10 squared, which is what? 100. So I'm going to have cubed root of 100 is equal to x. I can't do anything with that. I can't do anything with that. Okay. It's an exact answer. There's no decimals here. Okay. So it is an exact answer. All right. Oh, did you guys watch those videos? Any questions on them? Mary Alice? No? Becca, any questions on these two from the videos? Okay. All right, let's go down to number 8 then. Tip 1 or tip 2? How come, Abigail? Tip 2, she says. Yeah, it's a log equation. You know how I know it's a log equation? There's logs in there. Okay, I know, crazy how difficult that is. All right, and so what does tip 2 say? Abigail, you alluded to this. You said that if it's a log equation, I'm supposed to do what? Get the log alone. Oh, this is a problem. There's logs, not the log. How do I get the log? Yeah, this is rules of condensing. Rules of condensing. You learned from the video last time how to condense into a single logarithm. So that's what we want to do. We want I call them the PQP rules, the product quotient power, PQP. Okay. And so since I have here 2 logs added together, this is a product rule. Oh, great. Another rule to remember. Okay, so another tool for your tool belt. So we've got here that I can make log plus log into a single log of a product. All right, so here's my single log. What's my product? What am I multiplying together? And what would I get when I multiplied those two together? Equals 1. Now, can you go back to that tip? It said, get a single log, get it alone. Okay, we've done that part. And what does it say to do next? Turn it into an exponential. Okay, so here we go again. We're using our handy dandy E. So what does my exponential look like? 10 to the first equals 3x squared minus 13x. What's our goal here? Let's keep reminding ourselves of what the goal is.
So good.
Solve for x. Oh wait, this is a quadratic. Do we know how to solve quadratics? You better say yes. We spent an entire chapter on it in chapter 3, right? How many methods do we have for solving quadratics? 4. Can you remind me what they are? Quadratic formula, square root method,
The
zero product property, yep, for factoring, and completing the square. Okay, so a couple of thoughts. Square root method I can throw out on this one because there's multiple x's. Remember, the square root method you only want to use when there's a single x. So that one's out. I would also throw out completing the square. Do you guys remember the 2 occasions that I will complete the square? What has to be, what's the nicest way to complete the square? Yeah, when the leading coefficient is 1 and when b is even. Very good. And I don't have either one of those. So I'm going to throw completing the square up. It can be done, but it would be super ugly, right? And so that leaves me with, what did you say, Becca?
quadratic formula.
Quadratic formula or zero product property factoring. Okay, now either one of those requires a 0 on one side. I cannot factor and I cannot use the quadratic formula if these guys are split up. I've got to have my a's, b's, and c's all on the same side. So I have 0 equals 3x squared minus 13x minus 10. So I know that you guys want to do the quadratic formula, but squaring 13 just, I'm going to try factoring because I like factoring. Now, you know what? You know how many times I've tried factoring and then I get to the end and I'll go, oh, factoring wasn't an option. I guess I have to do the quadratic formula. That's okay. That's okay. All right. So what could I use for my firsts? 3x and x. Okay. So that one was pretty. And forget pluses and minuses. What could I use for my last numbers? 2 and 5. Now, before I do anything, let's check this out. What would these two give me? 15x. And what would these two give me? 2x. Now, I need a negative 13x in the middle. So how would I get a negative 13x? A minus on the 15 and a plus on the 2. All right, so the plus on the 2 would look like this. And a minus on the 15 would look like this. And when I'm checking my work and I multiply my last together, does it work out okay? Yeah, it does. So, hey, guys, I think that was easier than the quadratic formula. I know you disagree. Okay, but I'm gonna stick with it. Okay, so then can you just solve the first one mentally? X equals negative 2/3 or x equals 5. Now let's stop here for a second. Let's camp out for a minute because there's something that I haven't talked to you about. Now, I might have talked to you about it in the videos. Did I talk about checking your answer in the videos? Do you remember? I did? Okay, yeah. So what was the newest rule that we came across today? You cannot take the log of a negative number. So do you remember back in the previous chapter how we had to check our answer to make sure that it was a good answer and didn't cause, okay, so you remember that. It's the same thing here. We have to check our answer and make sure that our answer doesn't cause any problems, okay? So take a look at your x equals 5. If I plug that in right here, does it cause me to take the log of a negative? No. If I plug it in right here, does it cause me to take the log of a negative? 3 times 5 minus 13. That's good. Okay. What about this guy? If I take this guy and I plug it in, does it cause me to take the log of a negative? Yes, it does. Throw it out. You can't use that one if it causes you to take the logarithm of a negative. So it sure looked like it was going to be a good solution, but we had to throw it out because it would cause problems. Okay. I would say that in this section, that's one of the biggest mistakes students make is forgetting to check. Like giving me all the answers and not throwing out ones that need to be thrown out. Okay, so watch out, beware. Okay, let's look at number 9. You want to try number 9 on your own? It's the last one. Try number 9 on your own. See what you can do. And when I say on your own, I actually mean you can work together. Without me is actually what I meant. This one's funky for the record. Before you get too far, what are you doing on the left side? What is it? Condensing on the left side, okay? I would do the same. And here's a hint. I would leave it over on the right side. You could, Abigail, but I'm gonna actually show you an easier method. You could bring it over by subtraction and use the quotient rule, but there's an easier way if you leave it on the right side. Okay, so get the condensing done first and leave the right hand alone, and then we'll talk. What's that? What do you mean? Did you condense on the left? Okay. Okay, is everybody at the same place? Did you condense on the left? Okay. What's that?
I keep going.
Oh, okay. So if you condense on the left, what do you end up with?
Log 2 times 2x squared plus 2.
Okay, 2x squared plus, what'd you say? 4x. And remember, this is not a log times, it's the log of. And I'm gonna copy down the right side, log base 2 of 16. Okay? It would be totally legal to subtract log of 16 on both sides and make this into the quotient rule. Because now it's a log minus a log, and so you could have the log of a quotient is equal to 0. Okay? Totally legal. But let me remind you of something we did back in section 6.2. Do you remember in 6.2, what was the tip I kept giving you guys over and over and over and over and over again in 6.2 when we were solving equations, exponential equations? Get the bases alike. And remember, there was logic involved in that. We said, if your bases are alike, then logically the powers have to be alike. Remember saying that? This is the same concept. Take a look. Are these equal to each other? Well, yes, they are. There's an equal sign there. And notice I've got a log base 2 equals a log base 2. Well, logically, if log base 2 equals log base 2, then whatever I'm taking the log of also has to be equal. So I can make a mini equation. Don't think I'm just throwing out logs. I'm using logic here. My bases are alike, so I can logically set up a mini equation that says 2x squared plus 4x is equal to 16. Because that's a mini equation because of the fact that I've already established that I have a log equal to a log. Does that make sense? Now, would you rather do this, or would you rather say, well, how about log base 2 of 2x squared plus 4x over 16 is equal to 0 and turn that into an exponential? It can be done. It's legal. You could do it. You have the ability to do it. Okay, but I feel like this guy's easier when I'm using the logic and setting up a mini equation. Okay, so then how am I going to go about solving this guy? subtract 16. Is there anything else I can do at the same time? Yeah, everything has a multiple of 2 in it. So what I'm gonna do is I'm gonna do both of those at the same time. Let's divide everything by 2 and let's move the 16 over. So when I divide everything by 2, what will that be? Okay, it's a quadratic. Man, I told you I was gonna make you guys do this one. You guys do this one. Finish it. I just stepped in and took over. Such a bully. So I'm curious, what quadratic method did you use to solve? Factoring? Factoring? Factoring, what'd you use? Quadratic formula, Becca, what'd you use?
Factoring.
Factoring. I'm gonna use completing the square.
Yes.
Because I've got a 1 out front, I have an even number on the inside, and it's a good time to review it because it is gonna be on your exam, right? So remember that with completing the square, the first thing that you wanna do is get your constant to the other side. So I have x squared plus 2x is equal to an 8. Do you guys remember the completing the square steps? What's first? Take half of b, which is, okay, and do what to it, somebody else? Square it, which is 1, and do what to it?
Add it to both sides.
Add it to both sides. So I have my plus 1 plus 1. And then what do I do with my trinomial?
Factor.
Factor. So do you remember the shortcut for this? It'll be x plus 1 is equal to 9.
Square.
Okay. By
Take
way,
the square root of both.
Yes, take the square root of both sides, and I do think factoring would have been easier on this one, for the record, okay? So take the square root of both sides.
X plus 1 equals 3.
Plus or minus.
Plus or minus.
I guess that's the thing that factoring kind of combats. Like if you factor, you don't have to remember plus or minus. If you're completing the square, you got to remember plus or minus. So we got x plus 1 is equal to plus or minus 3. And then we're going to subtract 1 on both sides. So what's a positive 3 minus 1?
2.
And what's a negative 3 minus 1? Negative 4. Is that the two solutions you guys got by factoring? Should be. Are we keeping them both? No. What are we throwing out? The negative 4 has to be thrown out. Now, okay, in the last 2 examples, we threw out the negative. Do we always throw out the negative? No. No, 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 no. Okay. What if, okay, well, we're not gonna solve this because I'm making it up, and so I have no idea how it would turn out. But what if we had log of negative 2x plus blah, 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 and I came up with x equals negative 4, x equals 2. This time it would be the x equals 2 that gets thrown out, because that's the one that makes me take the log of a negative number, right? If I plugged in a negative 4, I'd be taking the log of a positive number. Okay, so don't just get into a bad habit of saying, oh, just throw out the negative every time, because a negative might be an okay answer, depending on what it does to the log in the beginning, okay? Any questions on that? On any of that?